Section 2.1 is on page 24, talks about linear equations. This is a massive deal for us. We just covered linear and nonlinear, and now we're talking about linear equations. If an equation is linear, there's a method of integrating factor. So this is something you didn't learn in calculus. This is a new trick, and let me elaborate on that really quick. If I wanted to solve the following problem, so I'm trying to figure out what is it that you take 3 plus t cubed times its derivative plus 3t times the function and gets you a 2t. If you glance at this for a while, do you notice that this is the product rule? Do you notice that this is the derivative of this and this is the derivative of that? That's like saying f times g prime plus f prime times g. Wouldn't that be f times g prime? So somebody figured that, look, if this is the case, wouldn't that be 3 plus t cubed times y, and you're taking a derivative of that with respect to t. And if you can recognize that, then guess what? If you just integrate the left and the right with respect to t, this here, this integral, will undo this derivative by the fundamental theorem of calculus. This will be 3 plus t cubed times y. The right side will be t squared over 2 plus c, and I can get y to equal t squared over, actually there's no 2, right? That would be t squared over 3 plus t cubed plus c over 3 plus t cubed. That would be the answer to the puzzle. That is, this is what you take a derivative of and multiply it by 3 plus t cubed plus 3t squared times whatever this is. That should give you a 2t. If you have some free time, try and play with that. And now that you know that, somebody looked at this and said, well, it's the same thing. Look at that. This is the derivative of that, and this is the derivative of that. So it must have been that somebody took a derivative of 2t plus 5t to the fourth. I don't like that fourth. Times y. Somebody took a derivative of this with respect to t, and that was 7e to the t. Again, if I apply the product rule, that's the left side. And if I integrate with respect to t, guess what? The integral and the derivative will undo each other. That would be 2t plus 5t to the fourth times y, and that will equal a 7e to the t plus c. And now I could say y is 7e to the t divided by 2t plus 5t to the fourth plus c divided by 2t plus 5t to the fourth. So in the beginning, I couldn't figure out what the solution is, what value of y will allow me to do this. Now I do know. And if I look at, and I'm just going to unclutter those, because those errors make things very messy. But I am going to point out that this right here is actually this, and this right here is actually this. So now, here's the key. Something I'm going to divert from the book slightly. Make sure that's a positive one all throughout, and that's going to save you a lot of work. First order, linear differential equation in standard form looks like this. So if I can have y times y prime plus whatever's in front of y will be my p, whatever is on the right hand side, we'll call it g. If you have such a problem and you want to solve, if calculus can't help you, let u equal e raised, you know what, let me use color codes on those, that will help, e to this p of t dt. Figure out what that equals. Multiply both sides by this u, and this becomes the product rule. This becomes simply u times p prime, times y prime, I'm sorry. So let's try that. If I'm trying to solve, and on these problems from number 2 and on, we're just after part C, you guys. So find the general solution of the differential equation. This says find me a y such that if I take y and take a derivative of y minus 2 times that, I should get t squared times e to the 2t. Well, this is a linear differential equation. Make sure that is a 1, and it is. If that's the one, then you could read what p is. You could let u equal e to the integral of negative 2 dt. Wouldn't that be e to the negative 2t? If I multiply this equation by e to the negative 2t, I forgot to give you a page with all the excitement. This is on page 31 in our book. So I will get here e to the negative 2t times y prime minus 2e to the negative 2ty. And if I multiply the right side, that's simply t squared. And guess what? I got it. This right here becomes the product rule. You must have multiplied what? E to the negative 2t times y, and you took a derivative of that. And you could check, derivative of y is y prime times e to the negative 2t plus y times the derivative of e to the negative 2t is negative 2e to the negative 2t. And if you undo the derivative with respect to t in this case, this left side will simply be e to the negative 2t times y, and this will be t cubed over 3 plus c. And I could say y equals t cubed over 3. When you divide by that, that becomes e to the 2t plus c e to the 2t. And if you have time this weekend, try that. Take a derivative of that minus 2 times that. You should get this. Now, something that we're going to start playing with. What would happen if I take the limit as t approaches infinity? Well, this is going to approach infinity, and depending on what c is, if it's positive or negative, but those two will dominate. So you could look at this as e to the 2t times t cubed over 3 plus c. Regardless of c, since c is a constant, this is going to approach limit as t approach. I wrote it wrong. Come on. If I take the limit as t approaches infinity of this solution, this will diverge. Alright? Number 4 is next. The same deal. I look at that, make sure that's a 1, and that's going to be the case in all of our chapters. If that's a 1, I look at that, that's first order, and it is linear in y. So I could let u equal e to the integral of 1 over t dt. That would be e to the natural log of t. I don't need the absolute value because t is always positive, and that's simply t. Those undo each other. So here, if I multiply both of these by t, I will get on the left hand side ty prime plus y equaling 3t the cosine of 2t. And if I think of this as, let's see what that is. That is t times y taken a derivative. And to undo that, I would integrate. The left side will become ty. The right side, if you let u equal t, a derivative of that, dv equal cosine of 2t. So an integral of that would be the sine of 2t divided by 2. An integral of that would be negative the cosine of 2t divided by 4. Remember that trick, a plus and a minus. That would be 3 times the product of those. That is t times the sine of 2t divided by 2. Negative times a negative is a positive. Cosine of 2t divided by 4 plus c. So ty will equal 3/2 t sine of 2t plus 3/4 the cosine of 2t plus c, and y would equal, dividing by t, 3/2 the sine of 2t plus 3/4t the cosine of 2t plus c over t. If they gave us initial conditions, we could find what c is. Now, if I take the limit as t approaches infinity, I notice that's going to approach 0, and that's going to be oscillating. I have a couple more to go. So if I go for the next problem, the same deal. This is not a 1. I make sure that's a 1. And the same deal. I could let u equal e to the negative 1 over t integral dt. And wait, was it a negative on the previous problem? Did I miss it? No, it was positive. Okay, very good. So u will equal e to the negative natural log of t. Again, I don't need the absolute value because t is positive. Make that a power. U will equal e to the natural log of 1 over t. Those undo each other. U is simply 1 over t. Multiply this by 1 over t. This would be 1 over t y prime minus 1 over t squared y equals e to the negative t. This is simply the product rule of what? Of y and 1 over t. If you take a derivative to verify that, if you integrate with respect to t, you will get 1 over ty equals negative e to the negative t plus c. Y would equal negative t e to the negative t plus ct. And if I take the limit as t approaches infinity of y, this will approach 0 because e to the negative t is going to dominate over t, and this will approach plus or minus infinity depending on c. If c is positive, it's going to approach infinity. If c is negative, it's going to approach negative infinity. And of course, if c is 0, then you're going to approach a constant. And I added another example just to make sure we touch on all values. Well, I'm going to let u equal, since that's a 1, e to the integral of 3 dt. U is going to equal e to the 3t. I'm going to multiply this by e to the 3t. I'm going to get e to the 3ty prime plus 3e to the 3ty equal t e to the 3t plus e to the t. And here, this becomes the product rule of e to the 3t times y. This is t e to the 3t plus e to the t. If I integrate with respect to t, I will get e to the 3t times y equaling, and the integral of those, this is e to the t plus c, and integration by parts once, integrate again, a positive and a negative, that will be t e to the 3t over 3 minus e to the 3t over 9, and y would equal, dividing by e to the 3t, t over 3 minus 1/9 plus e to the negative 2t plus c e to the negative 3t. That would be my solution. If I take the limit as t approaches infinity of this y, I will get, this will approach infinity, minus 1/9 plus 0 plus 0, that would be infinity, so I know this would diverge. And the last problem is number 10. I just verified my YouTube, so hopefully they'll let me put a video longer than 15 minutes. Let's see how this works. Again, this is a 1, this is linear, u equal e to the integral of 2 dt, u equal e to the 2t, multiply this by e to the 2t, that would be e to the 2ty prime plus 2e to the 2ty equals t. This is simply e to the 2t times y prime equaling t. Integrate with respect to t. I will get e to the 2ty equals t squared over 2 plus c. So here we get y to equal t squared over 2e to the negative 2t plus c e to the negative 2t. All what I have to do now that they gave me initial conditions, say y of 1 is 1/2 e to the negative 2 plus c e to the negative 2, and that equals a 0. So this is 1 over 2 e to the 2 plus c over e to the 2 equals 0. That's 1/2 plus c equals 0, c equal negative 1/2. Plug that in there, and the solution is y equal t squared over 2 e to the negative 2t minus 1/2 e to the negative 2t. That is the solution. And if I take the limit as t approaches infinity of y, I know that the exponential is going to dominate over t squared minus 0. That's going to be 0, so this converge. There's the homework. 1 through 7, only focus on part C, do number 9 and 11.